Hey guys, welcome back to the laboratory. In today's video, we are looking at how mixtures can be separated using distillation. By the end of the video, you should be able to describe how simple and fractional distillation are used to separate mixtures, and identify when simple and fractional distillation are used as separation techniques. So, let's go. Simple distillation is a separation technique used to separate a solvent from a solution, for example, water from a mixture of salt water. The technique is successful as the boiling points of the solvent and the solute will be very different, and in the laboratory, the apparatus used will look similar to this. Firstly, the solution is added to a distillation flask, and this flask will contain anti-bumping granules. Anti-bumping granules are added to control the boiling of the solution and to prevent it from bubbling over. Next, the Bunsen burner is used to heat the solution, and this is done until the solvent reaches its boiling point. A thermometer is needed here to measure the temperature as it increases. When the solvent reaches its boiling point, it will evaporate from the solution. However, as there are bungs throughout the entire system, the gas is unable to escape, and so is forced into the condenser. The condenser has a jacket surrounding it, with cold water running through it, so when the warm gas touches the surface of the cold condenser, it cools and condenses back into a liquid. The liquid is then collected in the conical flask. And voila! You now have your solvent, which is separated into the conical flask, and the solute, which has been left behind in the distillation flask. Fractional distillation is very similar to simple distillation. However, fractional distillation is used to separate a mixture of two or more liquids with similar boiling points. Take a mixture of ethanol and water as an example. Ethanol has a boiling point of 78 degrees Celsius, and water has a boiling point of 100 degrees Celsius. To separate these two liquids, your mixture of ethanol and water would be added to a distillation flask containing anti-bumping granules. The mixture is then heated using a Bunsen burner. Because the ethanol has a lower boiling point than water, it will evaporate from the mixture first and move into the fractional column. Now inside the fractional column, there is a temperature gradient. It is coolest at the top of the column and hottest towards the bottom. If the coolest part of the fractional column has a temperature higher than ethanol's boiling point, the vaporized ethanol will continue to rise and pass into the condenser. Now it's likely that some of the water from the mixture will begin to evaporate also. However, as the water vapor moves up the fractional column and reaches an area that is cooler than its boiling point, it will condense and fall back into the distillation flask. The vaporized ethanol will be cooled in the condenser and collect in this flask here, leaving the water behind in the distillation flask. Here's an example of an exam-style question that you might be asked on this topic. Pause the video, read the question, and take your time to answer. I'll be waiting for you on the other end with the mark scheme. This is a nice question, guys. Here, you've been given the boiling points of two different liquids that are mixed together. The question simply asks for you to explain the process you would use to separate the two. Your first marking point is for mentioning that you will be using distillation to separate these two liquids. More specifically, you would be using fractional distillation. However, the mark is still awarded for simply mentioning the word distillation. Your second marking point is for mentioning that the mixture will be heated or boiled. And your final marking point is for indicating that the nickel tetracarbonyl will be the first to evaporate and or condense. And this is of course because it has the lower boiling point of the two. So, how did you do? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!